All right, we've got synthetic division in front of us today. It's a really simple skill. I wish more kids got it. Synthetic division is supposed to be a skill that 99% of the student body gets because it's just not hard. First up is the remainder theorem. You're supposed to use remainder theorem to determine if any of the following are zeros. The idea here is if f of 4 equals 0, x equals 4 is a 0. That's the idea of the remainder theorem. So we're just going to plug 4 in. F of 4 is going to be 4 to the 4th minus 4 times 4 cubed, which is oddly enough 4 to the 4th, minus 8 times 4 plus 32. Now, for a lot of y'all, that's a big number, whatever. 4 to the 4th ought to be 256. This is 4 times 64, which also happens to be 256. They're going to knock each other out of the park. Negative 8 times 4 is negative 32, and then you have plus 32, and they're going to knock each other out of the park, and you get a 0. So, this is true. Since f of 4 is a 0, then a factor is x minus 4. That's remainder theorem. That's how she works. All right, instructions on the next set. I'm not going to do a lot of synthetic division. Divide the following using synthetic division. State if the divisor is a factor or not. And we are dividing by x minus 4. So since x minus 4, x equals 4. Just think about shifting to that imaginary equal sign. Think about shifting it over. That's a big mistake a lot of kids don't do. They just accept whatever sign they see and they go with it. Now this one is in standard form, but for division purposes, it's missing something. It's missing 0x. You need that placeholder. We're going to think about the coefficients here. The coefficients are 1, negative 5, 0, and negative 2. And our acronym here was DMA. We drop, we multiply, and we add. So we drop the 1. 4 times 1 is 4. Negative 5 and 4 makes negative 1. 4 times negative 1 is negative 4. 0 plus a negative 4 is negative 4. And 4 times a negative 4 is negative 16. And we get negative 18. I need to make sure we list the quotient and remainder. This is going to be, if we think about how things are, this is my remainder, my constant, my x squared. So it turns out that when you do this math, you get x squared minus x minus 4 minus 18 pieces of x minus 4. That's what you get. Now, was the divisor a factor? Divisor is not a factor, as the remainder is not 0. Only a factor if your remainder is 0. So there's that one. Number 9 is a completely factoring kind of deal. You're going to use synthetic division to pull something out, and then you're going to factor what's left. So given polynomial f of x and a factor of f of x, factor f of x completely. That's a mouthful right there. The divisor is not a simple x minus a constant, so you have to use long division. Long division is really where it's at. I like synthetic division because it's easier than long division, but placeholder. It's just not as useful. I kind of wish it wasn't in your standards. Another placeholder. It's easy to forget about those placeholders. This might take a couple steps. To turn x squared into x to the 5th, we have to multiply by x cubed. Then we distribute x to the 5th minus 3x cubed. Oh, this is going to be nice. Look at all that stuff that just canceled out. Right before you subtract, 0, 0, 0, carry down, And I'm going to carry down that one too. To turn x squared into a negative x squared, we multiply by negative 1. That'll give us negative x squared. Negative times negative plus 3, wrap, subtract, 0. So this is another factor because the remainder is 0. So here's how, so far, we factor as x squared minus 3 times x cubed minus 1. That's how we factor. Now, there's a couple of you guys who can factor this now. This is actually, believe it or not, a difference of two squares. This guy right here is. A is x, and b would be the square root of 3. And we're going to use that pattern a minus b, a plus b. So this is going to factor as x minus root 3 and x plus root 3. Probably should have left some more room here. This guy is the a cubed minus b cubed pattern, where a is x and b is 1. Because if I cube an x, I get x cubed. If I cube a 1, I get a 1. And again, I should have left some more room here. So maybe 5 of you have memorized the difference of two cubes pattern. Like that's what's killing you. A cubed minus b cubed factors as a minus b times a squared plus ab plus b squared. That's how she factors. So if a is x, I'm going to put an x there. B is 1, I'm going to put a 1 there. So x minus 1. I have to square the x. X squared. Plus because there's a plus. 1 times x is x. Plus because there's a plus. 1 squared is 1. And that, boys and girls, is the complete factorization of number 9. Number 11 is also a factor completely. You are given a 0. Since f of 7 is 0, x minus 7 must be a factor. So that's what I'm going to use. And I'm going to do synthetic division. I'm just going to take that 7. I'm going to keep that 7 right there, put it right there. I got a 10 for a coefficient. I got a negative 81 for a coefficient. I got a 71 for a coefficient. And I got a 42. And I drop. And I multiply and I get 70. And I add and I get negative 11. I multiply and I get negative 77. I add and I get negative 6. I multiply and I get negative 42. And there's my 0. All right, so here's what I know. So far, I factor as x minus 7, remainder constant x squared, and then 10x squared minus 11x minus 6. That's how I factor so far. Give me a second, I'll be right back. You'll never know from your end. All right, so now we're going to factor. Algebra 1 skill. I swear it is. Algebra 1 skill. Swear it is. Swear it. Factoring is not an Algebra 2 skill. It is an Algebra 1 skill. To create a 10x squared, we need a 5x and we need a 2x. To create a 6, we need a 2 and a 3. The outside makes 15, the inside makes 4. A negative 15 plus a 4 is a negative 11. She's factored. All right? That is the complete factorization because you can't factor anything else out of it. Geometry. You were given an expression for the volume of a rectangular prism. Find an expression for the missing dimension. And the hint here is to try using synthetic division. So that's what we're going to do. So this is a factor, which means x is 1. This is another factor, which means that x is negative 6. Because when you create factors, you change the signs and vice versa. And we're just going to do synthetic division. My coefficients here are 1, 13, 34, and negative 48. 113.34, negative 48. And I'm just going to pick the 1 first because the numbers are small. And I drop the leading coefficient. I multiply and I add. I multiply and I add. I multiply and I add. And I got a 0, as expected. Now the nice thing about synthetic division is if you get a 0, just reuse what you have. So now I'm going to pull out a negative 6. I'm going to drop the 1. Negative 6 times 1 is negative 6. When I add, I get 8. Negative 6 times 8 is negative 48. And there's my 0. So this is my remainder. This is my constant. This is my x. After successfully dividing out two factors, I have a remaining factor of x plus 8. And that, boys and girls, is what goes there. That's the missing piece. All right. Looks like I got 15 marked off. Use synthetic division to divide this thing by x squared minus 1. It says hint this thing factors, so you can factor it and do synthetic division twice. So let's do that. X squared minus 1 is an a squared minus b squared pattern. And a squared minus b squared factors is a minus b times a plus b. So what's squared here is x. So a is x. What's squared here is 1. B is 1. I just plug into my little pattern. X squared minus 1 factors is x minus 1 times x plus 1. If something factors, you can actually turn around and do synthetic division with it. So I'm going to go after the first one here where x is 1 or x is negative 1. So if x is 1, I got a 12, a 3, a negative 12, and a negative 3. And I drop, and I multiply, and I add, and I multiply, and I add. That should be positive 3, shouldn't it? And I multiply, and I add. And then I'm going to go ahead and do it again. But this time I'm going to use the negative 1. And I drop, and I multiply, and I add, and I multiply, and I add. And we're going to do this to factor completely. I need to modify the instructions. All right. So remainder, constant x, the missing factor is 12x plus 3, which also factors, as 3 times 4x plus 1, because you can pull a 3 from both terms. So my complete factorization is 3 times 4x plus 1 times that stuff right there. X minus 1 times x plus 1. That's my complete factorization. A lot of kids are probably wondering what a complete factorization is. You know, you talk about 50. What is 50's complete factorization? Well, it just depends on how you approach it. I mean, you know, you might think, okay, 50 is 5 times 10, right? It is. But, and again, but 10 is 2 times 5, so it might just be written as 2 times 5 times 5. And don't forget the 1. That's the complete factorization of 50. The same thing with polynomials. Write it out as much as you can, and you get the complete factorization. And that is your 3.4 synthetic division assignment. How much did I do? I did 1, 2, 3, 4, 5, 6 of 16. That's pretty good, actually.